It's good afternoon time.
Good afternoon time.
It's not good morning anymore. Super thrilled to be here to support Barry. He's done a lot over the past couple of years to support me, probably more than he should. I don't really know why he does, but somehow or another he's taken a liking to the Texan and he's helped us come do training. I picked up on a couple of things. I kind of feel like a fish out of water because this is big on air ventilation, quality of air tightness testing. I'm in that realm, no doubt about it. But I'm more towards the building envelope side, and we think more in the States about keeping the water out, and air is kind of secondary. We pressurize the building, and that also helps keep some of that weather out, but we really haven't focused much. I would say we still aren't focusing much on air tightness in the States. When we started getting into, when ZeroSix, my company, started getting into air tightness testing, probably 3 or 4, and maybe 5 years ago, I'm losing track of time. I thought it was more of a plug and play type of thing. You know, we had spent lots of time getting trained up on our kind of testing, and our testing is more like Mythbusters. We have to build our stuff, you know, and we test it, and sometimes it fails. A lot of times it fails, and you throw it in the backyard, and you build something else. It's cool to be in a world like air tightness where people are actually building the equipment, and we can buy it and use it with some confidence. That said, when we did it 4 or 5 years ago, we knew how to operate the equipment. I didn't really feel like we were very competent, okay? And we were I am a critical person. If you want to find something wrong with something, ask me, and I will find something wrong with it just because you asked me to, right? Sometimes I will volunteer it. I'm just a critical guy. I knew we weren't competent to do the air testing. I watched my guys do it. And I was like, this doesn't look like a regular operation of ours. I don't like it. And we started rooting around, and we found Barry. We actually hired Barry to come to the States to train our guys and to train other people. And we found out we weren't doing it that bad. We probably could have been, and we could have been doing it better. We should have been doing it better. What we found out at the time was in the States we really had a bad standard, okay? And I don't know politically wise about, we've got a phrase in the States that says something like, when something is too easy, it's the everybody gets a gold star program. That's how our blower door testing stuff was for the longest time. On the commercial side, and they started putting this in terms that I could understand, and I want you to understand that I'm not competent to be a air tightness tester, okay? I'm more of I'm a conductor of an orchestra kind of guy. And there's 15 or 16, however many different instruments being played, and I can totally rock 2 or 3 of them, but not all of them, okay? So I understand the importance of assembling a team and getting those specialized people together. I feel a little funny talking to you guys about competence, because if y'all were the problem, you wouldn't be here, right? Y'all are the solution, you're probably not the problem, right? So when we talk about competence, and I think everybody in the construction industry, I'm an architect. Are there any architects or engineers in here? Architect or engineer? Architect. In the States, and I don't know about over here, but in the States, architects have not become a very technical profession. I graduated back in 1984, so I'm not a young man, from a place that brags about being a mechanical college, and I didn't come out of college a very technical person. I came out very artsy. I knew about planning and that sort of thing, but not very technical, okay? I also architects as a profession are very confident people. We've got very specialized training in very few things, generalized training in a lot of things. So when you go on a job site and the architect is that guy that has the last word, you're thinking, is that really the guy that needs the last word on this? And that might be part of the theme of this conversation is, who's making that decision? Are they competent? I made some notes as other speakers were talking, thinking about air tightness testing, and I view the building envelope as a big duct. Okay, so if my stuff doesn't work, the mechanical contractor stuff isn't going to work. I think of air tightness testing. Get it all out. I'd laugh at it kind of, especially in the States, because we'll come in at the end of a project and do air tightness testing on a project that has had no other commissioning activities. So I'm like, man, that is like going to a college exam to take the test, like the final test, right? The final exam, and you didn't ever go to the class. You didn't crack a book. You didn't, nothing, but I'm going to go test it and I'm going to pass. That gets back to my everybody gets a gold star program. If the test is so loosey-goosey that anybody can pass it, anybody can get a gold star, well, yeah, then you've passed it. But at the same time, are we really doing anything? I think the standards are tightening up now. As the standards are going to tighten up, then we're all going to have to be more competent about how we get to that final exam. It's not going to be one of those things where we can walk up and we're just going to take the test and we're all going to pass. We're seeing that over the last 2 or 3 years in the States, that standard really get tighter, and it's going to start there. I think what we say in the States, we're going to separate the men from the boys, right? It's going to be the heavy hitters. You're going to have a better plan to get to the end to pass that test when the standards really get to meaning something. And Barry and I talk a little bit about difference in standards between here and there. Y'all's air tightness standards knock us out of the park. We don't have a standard compared to y'all's right now. It's particularly not compared to the ATMA standard. On some of the other standards, I think that's a way that we can help y'all. So that's why we came over here from the States. We want to share some things with y'all. We want to bring some things back. I want to recruit you guys in some manner. I don't want y'all to come to the States, although you're welcome to come to the States. What I mean by that is we'll all get on the same page. Every time I start a talk like this in the States, I start off by saying we're not on the same page. Nobody's on the same page. I pride ZeroSix in being a building envelope commissioning company. Okay, and so when people call us and say, I want you to do building envelope commissioning, I always ask them, well, what does that mean to you? Because it means different things to different people. And they say, I just want you to do what you do for everybody else. And I said, well, hold on, because we do the whole thing. So, get your wallet ready, get everything ready, be prepared to, take a deep breath, because it seems like the norm in the industry is building envelope commissioning means whatever resources I have, I'm going to use the skills of those resources to commission your building. Not what your building might necessarily need, but the resources that I have. And that's a very dangerous way to move forth. Your building needs the resources that it needs, not the resources that one particular company has to offer. And it can be, I don't feel like I'm really communicating that very well, but it's whatever talents you have in your stable, so to speak. People are preparing plans based on their talent and not necessarily the talents that's needed. I don't know that very many companies have all of the talent under one roof. So I heard another word earlier about collaboration. All of us are going to have to become friends. If I'm really good at water and you're really good at air, we're a team. Okay? And I think it's going to take 4 or 5 of these guys. It's going to take those guys, that 14, 15, 16, however many instruments are in an orchestra. We need all those guys. And then somebody that can conduct. That's just a good organizer. Maybe what you call it, jack of all trades, master of none. That could be the conductor with a bunch of masters of those trades. So my 2 minutes per slide is shot to what. And we're going to get on down the road here. What am I doing wrong, Barry? That's what I'm doing wrong. Forget all the words about copyright. I just want to explain the relationship between BCTA and ZeroSix. BCTA is trying to be what Barry's group is over here. We're trying to assemble people that can teach. I kind of compare it to the American Institute of Architects in the States, just format-wise. It's an organization that goes and gets other people within the trade to do some teaching. So ZeroSix does some teaching on behalf of BCTA, ATMA, SITMA, all of Barry's organizations have come to support BCTA in the same role that ZeroSix does. Now this was put out with the flyer because Chris maybe put something to tell you guys what this is going to be about. Long story short is I don't know that anyone out there is intentionally not competent sometimes. Everybody wants to get the training. They want to be competent. Everyone is confident that they are competent. At what point is confidence cocky if you don't have competence? Just because I'm trying to, why isn't my video rolling, Barry? I broke it. No, there it goes. So in the States, we like to use pre-engineered buildings such as this one and make churches and schools and everything out of them. The transitions from walls to roof are terrible. In this particular scenario, I don't know with anybody other than maybe the design team actually was incompetent. But the bottom line is this is a very young building, but constructed per the modern codes, and it leaks like hell. Okay, I mean, we pumped it full of smoke, and I don't know how well you could see these TVs, but that's a big building with one source of smoke. We're not walking through there with it was one of these concept or whatever that over there, a smoke dragon. Puts out a lot of smoke, but it was a big building. It looked like it was on fire. Fire department came. That type of a thing. No, it's not on fire. It's just really loose. And there's just not that much at the end of the day that where you can reel that in without spending significant money. Small churches in Texas do not have significant amounts of money. That was a bank note, a fundraiser, and who knows what all went on to get that church built to begin with within the past 10 years, right? For it to be that, there's not an amount of money to fix it. You have to go in and do the best you can. We'll go through just some few. Chris is not going to show me that sign. I'm going to make it. Just some few applications that we see. We've got volumes of what we call lessons learned, deals gone bad, however you want to describe it. In our world, these little residential windows have become a real challenge when they have notched corners. And then they come in this particular DuPont system, and I do have my little pointer there, leaks like a sieve. These are brand new. This is student housing that was made probably or constructed 4 or 5 years ago, major university in Texas. We have to show them time after time. This is done. There's a rule now with the University of Texas on all their student housing that we water test 10% of their windows. And typically there's 400 to 500 windows in one of these things, okay? If they fail more than like 70% of those 10, then we have to test 100% windows. So if you're a testing company, and imagine that that instead of being an air tightness company, you're a water testing company, and you're scheduled to go out there and test 10 windows. 10 windows can be done 2 days, okay? And then all of a sudden they fail, half of them, and you're instructed you have to be there now for now start dividing 400 windows by 10 per day. Now all of a sudden you're in a different realm and you've jacked up your entire schedule. Imagine you guys just as air testers, if you decided that you need to do one house in the neighborhood and then you were told you had to do the entire neighborhood. How do you even get that manpower? So it's not just about quality, it's about affecting the whole, that impacts our business when we do that. We want them to pass. We tell everybody, we want you to pass, because I need to be somewhere else tomorrow, and I can't be here for 3 weeks. So that's another reason to get everybody on the same page and just do a little better. Oops, going the wrong way. This is a balcony in Texas also. It's a waterproof balcony. It's a single-ply, self-adhered membrane, about where that little red arrow is. And this gets back to competence. On residential projects in the United States, there typically isn't anybody on the job that's really good. It's a really broken industry. But for some reason, the waterproofer tends to be a pretty good guy. And I don't know if it's because they think, man, we always have trouble with balconies, so I'm going to go get a really good waterproofer, and we're not going to have that problem. Well, the problem is that 3 or 4 or 5 different other trades are interacting with this guy. It really doesn't matter how competent he is. If the baluster, the rail guy comes through and pokes 4 lag bolts through the middle of it, there they are, 3.5 inches long or what have you. There's nothing, and when I say my guy, this particular client, we do a lot of expert witness work. So now this particular contractor, he's become like, I have to send him a turkey at Christmas and stuff. He's too good of a customer because he does too many residential, and he needs a quote-unquote expert. We've become his expert when he gets sued. And if you have the name waterproofing in your name and the job goes down, you can bet if you did your job perfect, you're still going to get sued because you got waterproofer in your name. The lawyer keeps telling him the best thing you could do to defend yourself is just take waterproofing out of your name. Call it something totally different, because he always gets collected. And even on the side over there, you can see how that lag bolt has gone through the wall. So I've got 3 or 4 different points of water infiltration on this thing. You know, our guy, our waterproofing guy, was pretty competent. He did a good job, but the folks around him weren't very good. So it's not enough to take care of yourself. Now you got to take care of the guy with you, right? Residential roofing, whoo, what a disaster. You know, steep slope roofs, we always say, you know, steep slope roof, you can't hardly go wrong. You know, build it steep, let the water get off of it. But the minute it starts interacting with anything else, and, you know, dormers, any kind of, you know, a hip return, what have you, chimneys, we start having issues. That is exactly the same photo 2 weeks later. And I wished it was a bigger, and I wish my picture was better. But basically the water infiltration from around that spot there and up here eventually just rotted off the wall. So, I mean, this is the exact same, all that is just rotten. That is within, that's a 3.5, 4-year-old wood project. So, you know, one little point of water has gotten in there and ruined an entire wall. At that point, it's almost hard to say, you know, the roofing and the flashing stuff is not great, but it's also exactly the way it was drawn. So not very good on our part, the architect's part. Another one, you know, talk about competence, and this is getting back probably more to the design, but that little roof back in there was, it just didn't meet the minimum slope for that type of product. So everybody that walked by that, you know, the roofer, the architect, the framer, you know, these are like coffee top, you know, conversations. This is like everybody, you know, if you've got a composite roof, the minimum slope's 3 and 12 or 4 and 12, depending on what manufacturer you've got. We've got a 2 and 12 roof. You know, it's noted on the drawing as being 2 and 12. You know, in that case, everybody that looked at it was incompetent. You know, the guy who drew it, it got through shop drawings, it got through the lumber place, the inspection on the roof. You know, how many people have to look at something before it's wrong, and then while they're up there looking at that, you know, whatever that other little parapet condition is, maybe they would have saw it too. These are more subtle, and I mean, you'll tell by looking at this, we have a lot of, most of our new work, our non-legal work is commercial. It's going to be larger commercial projects. Where we get drug in on the residential side is going to be on the legal. So most of my photos on the legal side are pretty colorful. But every once in a while, this was actually a utility company, and it was built to survive an F-something tornado. Okay, because the data center for all the utilities for Corpus Christi, Texas, and that surrounding area came into this building, so it was made to just almost be a bomb shelter. And it had an architect with a lot of experience, or a firm at least with that type of experience. So here we go, and we've got, you know, probably one of the better contractors in that area, general contractor. You've got a mason that's high quality, a roofer that's high quality, but at the same time, I don't know how well y'all can see those little blue lines, but in today's world, I mean, in the day of old, the bricks were like in Amersham or whatever, where we're staying, Barry, however you pronounce it, right? Big masonry mass walls. Water can't get through them. There's no cavity back there. The wall absorbs a lot of water, but it typically just doesn't get through there, and your hope is that by the time it's getting to the other side, it starts to dry out and it evaporates out the other side. In today's cavity wall construction, you know, there's a void behind that brick. Water gets behind that brick, it goes straight on through it, it gets to the back side of the brick, and it just rolls down. We collect it with flashings, and we evacuate it out the bottom of the building. When we have a roof hit a rise wall like that, and we don't flash through it, well then, and roofs, and I don't know what they cost here, but that little, and I know that's a terrible excuse for taking care of a roof, but $25, $30 a square foot is what we're paying for a low slope roof. We're paying a tremendous amount of money for low slope roofs. We're also installing them over continuous insulation, which doesn't want to get wet. You know, there's 2 things about getting insulation wet on a roof. Number one, whatever glue was sticking that roof down, if it gets wet, it's going to release. So in my area, where we get a lot of hurricanes, you don't want your roof releasing. It's got to stay stuck. When we commission roofs, we go in there with it, and you'll see a little sample of the machine here. We want to make sure that it stays stuck. The other thing about wet insulation is the only reason we do it is because we've gotten sensitive about R value. We want things to perform better thermally. Well, if it gets wet, I lose R value. We start talking about things, even with insulation today, and I don't know if it's as much of a topic here. LTR, long-term R values. You know, I know what it was today, or know what it is today. What's it going to be 3 or 4 years from now? So if you've got a building that's been touted as being and I don't know if you guys use LEED, but we've got this energy program, Leaders in Energy program in the States, where you can be LEED Gold, LEED Platinum, LEED Silver, what have you, based on how your building performs the day you commission it or the day you occupy it. It's always interesting, you know, how do those buildings perform 5 years from now, 6 years from now. This would be a good example because it's not going to take very long of water to hit that wall for it to roll behind that flashing. It's not, you know, it's going to get underneath that roof system. It's going to ruin the roof system. And then 4 or 5 years from now, probably what that means in the States is you're past substantial completion for sure, you're past final completion, you're past warranties, and if you're past 4 years, you're basically past the point you're going to get sued. Okay, so you've got a lot of buildings, particularly in the States right now, 5 to 10 years old that are kind of blowing up because we've been bad at it for a long time. We're just building more things and getting more exposure. But man, there are so many buildings on the market or within the marketplace that are just roofs blowing up, you know, been fully commissioned, did a lot of testing at the time of construction, and now, you know, they aren't holding up long term. This is another one, especially with the gain of, or the popularity of solar power, you're getting a lot of supports on roofs, and especially down in an area that the tendency is to hot dip galvanize them. So we've got these drain holes at the bottom of, so when they dip them in the galvanizing rolls out, and it doesn't just stay in the tube. If the tube's hollow and that's in a roof, then it's a chimney and it's going to collect water. That building was one of these ones that was supposed to be a, you know, it's so energy efficient and it's so sustainable and it's, you know, all this other stuff. And we got this great, it's a university building. That building probably takes up 5 to 6 city blocks. It's a, you know, it's a swooping, it's like a banana. It comes, you know, it was a designer architect and an architect of record that all collaborated on this thing. And it was a pretty well designed, well everything, okay? It was a good building. Good players. This was another one that we did a lot of testing on. I think it was probably one of the first jobs in about 2008, 2009, somewhere that where ZeroSix got to go on it and be the commissioning guy. You know, we just didn't do water testing. We just, you know, we did the full Monty. We gave it everything we had. We thought we did a perfect job, and I think we did. But in this particular case, the galvanizer did not cap the tops of the post, and they were 20 feet tall. Okay, it's covering all this equipment that no one wanted to see. Water came down the tubes, got into the roofing system, you know, so we're supposed to be being green on that project, and we ended up putting, you know, tens of thousands of square foot of roofing into a dumpster because I had 1 million of those posts going through the roof. And, you know, I don't know at the end of the day who really wants to claim who wasn't competent for that, but it was a huge, huge deal. I don't know how well y'all can see it either, and I don't really know if it's a great picture to be shown this crowd. It's just, you know, that particular job was 2003, San Antonio, Texas, probably had the world's largest contractor, you know, somebody that was prepared to do it right. We had probably a top 10 architect globally. Competence was rich, but, you know, when it came down to certain details, you know, it gets back to that orchestra. You know, I needed a tuba player. Apparently all I had was a drummer. You know, the details just didn't work. I've got a rail that's too close to a wall. I've got a brick paver over in the corner that's hitting the flashing. You know, this job did not make it to final completion. We've got something we call substantial completion, and then you've got final completion. At substantial completion was when the punch list was done. That's, you know, they couldn't get through the punch list for about a year. They couldn't get all the deficiencies taken care of. And that was the first job that I think we ever did out of the city of Galveston. Another little, that same flashing detail from earlier. Water rolling behind the flashing, ruining the roof. That was an elementary school somewhere. Look at this little case study. That job was brand new, Houston, Texas. I say brand new, it was within, that one made it past final completion, but didn't get past the warranty period, and the contractor couldn't fix it. So we went in to see what was going on. It turned out that and air tightness testing was not a thing. If you had told me as the envelope consultant on this job that I had to do it, I wouldn't have known what it was, and I wouldn't have, I don't know if Google would have told me how to get it done in 2005. But let's see what else in here. Yeah, I mean, basically, where the weather barrier behind the brick tied to the windows, we could stick our hand into the interior of the building. There was no flashing. So if we had been able to air tighten it, it would have just come out. If we had smoked this building, it would have been another one that looked like it was on fire. We had to take all of the brick out over the heads because someone didn't want to include the stainless steel flashing. They had the peel and stick down on the lintels, but we always assume those lintels are like continuous. They're 100 feet long and there's no joints in them, right? Well, no, they were butt jointed and there was no call to weld them together. So as water came down every 20 feet where I had those lintels, it rolled down the flashing but got in that gap and rolled back into the building. So then 2 years after the fact, we're back in there pulling all the brick out, supporting it, taking the peel and stick off, putting more stainless steel down, flashing it back in, and then just for giggles, we throw this one in there because it's like, this is kind of obscure. You kind of get, that, hey, somebody, you don't think about the way the angles go together or whatever. But that one, the weather lap on the membrane is actually, it's inverted. So, I mean, I don't know. To me, I look at that and I'm amazed. I'm going, wow, if somebody on the house didn't know how to weather lap things going up or on any kind of a building, you're thinking, well, they were never going to catch that if they did that. This was a good one. This one back in 03, 04 or somewhere in that range. But you can tell it's a big building. It's a university building. It's back to that one we were talking about earlier. Huge contractor, reputable contractor, reputable architect, reputable everybody on the team. And we want call attention to that one little arrow down there at the bottom. They call us because they've got that. So we start looking a little deeper, and we look above it, and we've got that. That's when everybody acknowledges that concrete is not a waterproof product, right? Because if it's going to have cracks somewhere, it's going to make its way through it. Not only does it look like it probably isn't something that's healthy, imagine what's happening to the reinforcing steel, in that concrete. You explore a little further, up above it, turns out, this area is like a chimney. It's just a big pilaster, and it wasn't waterproofed at the top. It wasn't roofed at the top. You can barely see it. You may not even be able to see it at all. It's behind the picture. But anyway, those limestone caps, we always joke, because everybody wants to use limestone as some sort of an ornament around the building, and now also want to use it as waterproofing. Limestone makes an excellent water filter. It makes a terrible waterproofing. So water would come down this cavity, and it would collect because we did such a good job of waterproofing at the bottom that it couldn't get out. That's it. That one, if I sound like I'm shuddering, I'm freezing my rear off. It's got my teeth rattling. So, yeah, that one leak is how all of that scaffolding and everything else came to, because once you find something, I want you to look at this other leak, and I want you to look at this other leak, and before you know it, and there's actually two buildings that size that are connected on top of a plaza area that's all, kind of a below grade, half below grade, interesting project to say the least, but it got real daggone complicated because that condition existed everywhere. We ended up digging out the topping slab that goes around this entire thing, One thing that was interesting to note is that that contractor was not the same as this contractor, and that is a little hard to, basically that picture is that stone removed, but one contractor, the waterproofing contractor, came and waterproofed up to the top of the ledge and terminated and did a beautiful job. The other contractor, the damp proofing contractor, came down the ledge, terminated his just short of the other guy, and did a semi-beautiful job, but an area where the two tied together. So part of the water, this was one leak. We thought originally, you know, what else do you need to know? That's a smoking gun, whatever low-lying fruit, you know, all the water's coming from there. We fixed that. Found out we had to fix that too. So we ended up having to put another piece of stainless on it. This was a job that keeps on giving. I mean, the other case study was one slide. We're on, you know, slide 3 and still going. Somewhere on the Gulf Coast, every week, we are on a job pulling off stone or pulling off brick because that condition exists. You know, if you're ever going to have air tightness, even with the ventilation systems and stuff that you were talking about, you know, how many times can you scrub the air if you keep bringing bad stuff in? That's why I've got to get my duct good before all these other things can happen, or we're just fighting a losing battle. We literally have a picture of somebody sticking their hand through it. So, also when we talk about air tightness tests, I have my own time. 5 minutes. You know, day one, it's easy to be airtight, especially if, you know, when Barry's talking about paint to paint. You know, we're doing air tightness paint to paint. As long as whatever the paint is attached to is holding up. If we're constantly soaking it from the backside, when we come back and air test in 5 years, all that's going to be disintegrated, and I don't think we're going to perform as well. So that's the part where we all need to start working together. Another little horror story. That's a gap, that's a hole, that's an anchor for the stone where they've blown out the back of the stone. Ideally, we would like to have about 2/3 of that stone bearing on that angle. We obviously don't have that. Typically, we wouldn't tape the curtain wall, but we did. We still have to seal it some way. We need a flashing. We're going to move through some stuff pretty quick. There's some things at the end I want to show. I don't know if anybody knows anything about roofing, but I don't know how you get in there to roof something that's 4 inches wide. Once again, you know, no matter how good of a roofer you've got, they can't conquer some of these things. This is what I want to show you. There's some of the, when we talk about testing, you know, we're talking about, you know, tests that can complement what someone that, you know, maybe an air tightness tester is now. Let's see. We'll do tile testing. I mean, this is not normal, but as part of the commissioning process, particularly in Galveston for a while, the insurance company said, I don't want you to use tile because it blows off. And we had to prove to them, for clients that did want tile, hey, no, we can do that, and it'll hold up. Mock-up testing, I don't know who I was talking to earlier about mock-up testing. We do a lot. It was you, wasn't it? It was you, David. This is like, you know, 5th and 6th floor of a building. We just, you know, duplicated, plugged it in, tested it exactly the same. I think that was 15 and 16 floor. Water infiltration testing, when ZeroSix started, this was our money shot. Build a chamber on the inside, put a little negative pressure on it, spray some water on the outside, try to suck it through. Not a lot of water. Some of you guys that are air tightness guys, this is like a real easy test to transition to. It's called electronic leak detection. This is a low voltage version. That is a high percentage hit right now. I mean, there's a lot of demand for it, especially with the price of waterproofing. Before somebody is going to do a plaza or, you know, actually backfill a garden deck, a green roof, what have you, you run over the top of that thing and it'll find every little pinhole. That's a roof uplift machine. Not a real popular test because everyone does it wrong. If you test to the right pressures, which are typically about 1/3 of the pressures that everyone seems to want to test to, it's a very effective test. If you test to the wrong pressures, it ruins a lot of roof. Oddball test, that's a floodgate on a building in Galveston. It only has to work about once every 20 years, but baby, when it has to work, it better it better work. And there's Barry's blower doors. I think right now in the States, we're probably one of 2 or 3 companies that are doing multi-fan tests. When I tell you air tightness testing in the States is not a thing, it's not a thing. There are people traveling long distances. All right, we're out of time. But if I wasn't out of time, you've done some of those. Jip board, well, you'll get to me after this. If you over tighten it, it doesn't, if you over tighten 5/8 jip, then you have 1/2 inch jip. If you're looking for pull-out values based on 5/8, then don't overdrive. I don't know if this product has made it to y'all yet. If it has, be very careful. Concrete's not waterproof. Drains have to be at the level of the waterproofing. Vinyl on an exterior wall is evil. And that's it. What do you think? Where's Chris? Yeah.